Good evening. My name is Philip, as Stuart has said, and what an opportunity it is to share my experience. When I say Manchester made me, it's not because I'm here today and I'm in front of my old bosses like Bob and Professor Zoo and Rob, but actually it did. So I'm going to tell you why, and hopefully it's not going to be death by PowerPoint. So my Manchester experience, I'd worked in financial services for some time. I was a management consultant. I worked for KPMG. And I thought to myself after my first burnout, you need to do something different. I studied material science, metallurgical engineering for a bachelor's. And when my lecturers heard that I had moved into the financial industry, they said, what a waste. So I then decided that I was going to change career paths, and I moved to Manchester in 2008. But in 2008, one of the worst things that could happen to a young man happened in the global economy. So the recession came, and everybody in the previous year that had gotten a job was celebrating, but in 2008, not a lot of people had picked up jobs. But I came with a mission to make some good friends, join an interesting group, graduate with an MSc, get a job with an IOC, and then life would be fun. Well, that went well. It didn't actually happen. So, but part of it was I had a plan. When I came to Manchester, I wanted to build on what I had done for my undergraduate, and I'd developed an alloy then, so I wanted to have a patent and all of that. Again, didn't quite happen, but I had very, very good mentors. So I worked with David Canterbury. That was our D6 research group. This was the MSc part of it, and he took us for really interesting walks. So he said, and as you probably tell, I'm Nigerian by birth. So he said he didn't know all of the Nigerians that had not done military service because they would never be able to complete that walk, but we did in the rain for about 10 hours. So during that, we started talking about what I wanted to do after graduation. And I then got interested in doing a PhD. So I got 3 funded positions, actually 2. One here, very many thanks to Stuart and to David for offering me that position to work in D26 group. But the other one was somewhere else. And I later on discovered that if I had left Manchester, I would have left the biggest and the best group of corrosion scientists and the most knowledgeable group that I could come to build my career. It was obviously going to be another institution with a good name, but I think sense prevailed and I stayed back. So that was on the back of finishing the MSc course in 2009, and you can see some familiar faces there. I was very privileged to have won the Ross Prize, graduating at the top of my class, and I was then recommended for my first job, as many things sometimes happen. So I stayed and worked on an interesting project where we found out what had been causing hums on power lines, and this was a big, big problem for the national grid at the time. Luckily, I can talk about it now. I went to all those conferences for many years, and I wasn't allowed to talk about it because I signed an NDA, and we couldn't publish very much. That's one of the regrets that I had, but maybe one day we'll get there. So one of the things I picked up at Manchester was volunteering. So continued to do that until I graduated with a PhD in 2012. No, I finished my work in 2012. I came back later. That's a story for another day. But as they say, in academia, you get opportunities to move the needle a bit in terms of the science. I didn't know that I'd actually moved it quite significantly with the help of the likes of Stuart and a couple of other people. So we solved an interesting problem. So we were, for the first time, able to tell why there was so much noise coming from either a dry conductor or a wet one. And in particular, why the noise intensifies when you have a wet conductor. So for the first time in the high voltage lab, we separated all of that. So we talked about coronal discharge, and then we're able to identify that the droplets actually separate. And we have a very nice video. Unfortunately, I can't play that today. But when I found this document, I felt we had solved a really big problem in industry. And that's when all of these things started to line up. So I wanted to be part of a big project, and we had done something useful, and we had done something to solve a problem which sorted out the noise issue, particularly for those who had moved into rural areas. That project had a grant of about £1 million, which we worked on, but the outcome solved an issue for the national grid, which was billions, because they could go on to deploy the low sag, low noise AACR conductor. Didn't sound very fancy at the time when we were doing it, but there was a lot of fundamental understanding. So I learned things like XPS, material characterization, and surface science. So moving on, I then decided that I was going to go into industry and chase that IOC job, which I had wanted for so many years. But I still carried on doing things around volunteering. So that's me there talking to a bunch of primary 6 children in Scotland and telling them all about science and how I became an engineer and what I've been doing in terms of engineering, what you need to be good at for you to be an engineer. That's me on the plant. As you know, I work for INEOS. Now I'll touch on that in a few minutes as to how I got there. And last year, I was recognized by INEOS, which is an industry body, for my contribution. So I've been given a number of talks and participating in many industry forums. So I won an award there for my contributions to the engineering community. So I said Manchester set me up for success. Why is that? When I came here in 2008, as I said, I had very, very good mentors. And one of the things that I was told was, if you want to be a good corrosion engineer, you have to work for the service companies for some time so you get some fundamental knowledge of what's really happening in the industry. So I decided to do that, and I started with a small inspection integrity management company called CAN. And Steve knows all about that. Steve has worked with CAN for quite some time. And after around about a year, I then moved to Lloyd's Register, whom previous year had come and taken most of the students away, but unluckily in 2008 or 2009, didn't particularly make the cut then because nobody was hiring. So I got to Lloyd's Register in the end, and then eventually moved on to Atkins, but we were all providing services to a company called Talisman Energy, which is a Canadian company. When they upped sticks and left, they sold to Repsol, and that was a sort of 50-50 partnership between Repsol and Sinopec Group in China. So I worked as a corrosion engineer for some time, and then worked as an integrity engineer. So I was a bit of everything, if you like. Then after working in the North Sea, looking after a number of different platforms and becoming a lead engineer on these project teams, I then had the opportunity to go into the operating company. So I worked for Repsol for some time as a corrosion engineer again. And what was quite interesting about it was then I could really start to take decisions as to how we manage integrity, and that was where, again, it clicked. So, what really did Manchester do for me? I put this book here. I know there are a few students. There are a few students in the room. I put this book here. This was my notebook from 2008. I've still got it. There's some questions in here that were answered by a lot of people in this room. And I used that each time I want to go to the fundamentals, and I don't want to spend a lot of time talking to people or trying to teach them all of that information that I already have. Why is that? You need to have records that communicate that information, what's already in your mind, which is simplified to you, but very complex to all of these other people, because as has been said by many speakers, Garrett said it, a lot of people hear about corrosion, but don't understand a thing about it. And where do you start? How do you pass the message on? If you're standing in front of a CEO, how does it occur to them that this is the next big thing that's going to happen to the company? I stepped out to answer a call, and that's because some of our steam drums, which I will show in a second, now have cracks at the bottom, right? They've been operating for 30 years, but now we have cracks at the bottom. Why? Why is it happening now? So we've got a nexus between the way the materials behave, the aging of the material, which is coincidentally what I was doing with the aluminium, but now transferred over, and how we have been managing our integrity. So corrosion management, the sweet spot is in the middle. You need to understand how you've been operating the equipment, how you constructed it in the first place, and now how you're going to keep managing that and extending the life of the equipment. So as I said, I work for INEOS, and this is what I now do. So at INEOS, we have got, and this is INEOS in Grangemouth, so we have got a number of different equipment. So we've got a power plant which supplies steam to our world-scale cracker, which you can see there, has 9 furnaces, and we've currently just built and about to commission the 10th furnace. That's one of the projects I've been working on. That was a £60 million project, an expansion. And the steam which we raise from our power plants, some of them go as far back as 1968 vintage, now needs to be fed into this so we can get all of our cracking processes done. After the pyrolysis, we then go into making ethylene and then further supplying that to our users. We also have an ethanol, a synthetic ethanol manufacturing plant, which is at the back there, and we've got hydrocarbon export facilities. We've got a virtual pipeline from the States bringing ethane to the UK, and there are so many corrosion problems that you can imagine in this spectrum of assets. We had a big problem in one of our 1968 vintage boilers where we had corrosion fatigue rip out a wall. And this happened a number of times. We just repaired one. We spent £2 million, and that happened after 2 weeks of turning it on. No CEO wants to be in that position, having spent that sort of money. So that was me in there trying to decipher what had happened. And what happened there was the welding was terrible. So you need to understand that. And when you speak to these people and say, you need to follow the weld procedures, your PQR needs to be correct and all of that, and they don't understand it, that book helps. And all the people in this room put something in that book. Oh, I just skipped that. That's the cracked nozzle at the bottom of the steam drum. And if you know what steam drums are like, all of the nozzles at the bottom will behave the same way. The reason for that is the stresses there, and the nozzle design in itself inherently makes it possible for you to get that stress intensification. So I don't know if Andrew Sherry is here, but thank you very much. I remember that one quite well. That there is quite interesting because that was stress corrosion cracking that happened on a line that was operating at 80 degrees, but nobody thought that it could actually happen because the line was supposed to operate at minus 80 degrees. So have you understood what operations is doing to the plant? That happened, that change happened 20 years before the failure. I told them when we were discussing the failure, that failure happened 20 years ago. So you need to really understand what's happening to the material and what the impact is. So, as I said, I started off as a corrosion engineer, and that was the foundation that I had from my metallurgical engineering background and to corrosion. So these are all of the things that I have touched on, and one of the previous speakers touched on the technical side of education which we receive. So I had all of the skills from materials engineering. I learned about how you would design a CP system. I've gone on to design CP systems myself. I just talked about how process chemistry can affect the nature of the material and the degradation that so ensues. And I learned about RBIs from Paul Wood, from CAPSIS, when we were doing that in class. So the first time that I did an RBI was in class. But when I got into industry, lots of people were struggling with that. Why was it different? We did it, and it was hands-on, and it was done here. So those are the hard skills, if you like. And I've had to pick up many other things. I've done lots in welding and quality assurance, particularly of the new furnace that we've constructed. So that led me into this sort of integrity lead role, which I have at INEOS. And there I lead a team of about 12 engineers and subject matter experts, technical authorities, if you like, in looking after this, because we have to find out what has happened to the equipment, why it's failed, select new materials, and make sure that when we repair the existing aged materials, they are fit for purpose, fit for service. But I've had to learn many other things as well. So I've learned to communicate to business people. What does that really mean when we say an item's aging, when we say do not raise the temperature by another 10 degrees? I've learned how to motivate people, and that's something which I did do as part of my learning in Manchester, particularly during my PhD. And that makes me a different type of engineer because I can now lead. I can then motivate people towards a goal. I can galvanize a team. So like I said, I've got a team of 12 different experts across a spectrum of disciplines. So in a nutshell, what my job is today is risk management. I manage risk. And I couldn't do that. I wouldn't be able to do that if I didn't walk through this campus and if I wasn't taught by these great people here. I'm not going to do too much around this because I need to wrap up now. It's always difficult being the last speaker. But every single one of these problems that I have had to handle almost worked out the same way my coursework worked out. The materials in front of you, you've seen what has happened, or you can see what the process conditions are. And in this case, for example, it was only a small change in temperature that caused the problem in a highly reducing atmosphere. That was my Unit 4 coursework all over again. Okay, so I'm just going to go through this. And if you look at this cartoon, basically, this was Paul Jordan speaking to me and saying, you need to get to understand why you get different transport of anions through your oxide layers or the spinel which you form. To explain it all, we were able to do some elemental analysis to show where the different contaminants had gotten to and why it was so corrosive, why it failed. A big part of what I do now is microbial corrosion management. We had a big failure as part of which we found during the TAR, but again, educating people, telling them why it is that we need to understand what is being measured, what key performance indicators we have, and following the standards, and making sure that we have the right key performance indicators, using the right techniques. Last bit is about introducing new technology. So I've talked a lot about why my knowledge from Manchester was important, but how do you convince a CEO to spend a little more today and save a lot more over the next 10 years? By demonstrating that we can understand where corrosion starts, how to mitigate it, and how we can actually start preventing it by determining that aged insulation, for example, is not suitable for reuse. by knowing that when we apply insulation and apply the mastic there, it's important that we have the right QA/QC procedures. This is a novel technology that we've applied for the first time on one of our sites, and we're rolling it out globally now. We're going stateside with this. So, to summarize, what did I learn? I learned a lot about corrosion itself, but moving on from Manchester, and even while I was here, I started to learn that it was important to keep all of that information documented. So I've got my notes. I can refer to them anytime. Okay. Upskilling, I needed to keep developing myself and keep reading papers. Believe it or not, I still read a lot of papers that are produced by this wonderful collection of academics. I've gone on to then become really critical about everything we do as an operator. Why do we operate the way we do? And do we understand the plant that we've been running? And I've now been able to develop a team that can put in place procedures which ensure that we are applying knowledge in the right way to manage the integrity of our assets. So that's been my career story, and I wouldn't have done it without coming to Manchester. Thank you very much for listening.